Hi everyone. So today we're talking about imaginary numbers. Um, I couldn't make this stuff up if I tried. That's a real thing in math is imaginary numbers. There's a definition here for you to get down, but basically imaginary numbers are mathematicians' way of defining square roots of negative numbers. Okay? We've talked a lot before about how you can't take a square root of a negative number because, for example, if you think about the square root of negative 25, there's no way to write two of the exact same number that would multiply to make negative 25. Because if you had two positives, it would come out positive, and if you had two negatives, it would also come out positive. So there's no way for this to happen, okay? And that really bothered mathematicians. There's a lot of scenarios where this kind of thing shows up, and they didn't want to just keep saying, oh, no solution, no solution. So they came up with a system of naming numbers to represent square roots of negative numbers, and that's the imaginary numbers. So when I talk about something being imaginary, that's specifically what I mean, a square root of a negative number, okay? So here's the way they did it. They took the most basic negative number they could think of. They did the square root of negative 1, okay? And they said, we're going to call that I, because we're very creative mathematicians, and I stands for imaginary. So we're going to use I to represent the square root of negative 1, and then that's going to allow us to do a whole lot of stuff with square roots that we couldn't do before, okay? So I'm not really kidding here when I say this is something that mathematicians made up, right? They made this up as a way to solve problems that they couldn't solve before. So, for example, when you look at this first problem here, square root of negative 25, which I realize I just crossed off up in the corner, we could think about this, think about what we did yesterday when we were breaking down the square roots. I could write this as square root of 25 times square root of negative 1, okay? Well, square root of 25 we know is 5. And then think about what we just said, square root of negative 1, we're now calling I. So we would just say our answer here is 5I, okay? So the square root of negative 25 is 5I. Now, that's a whole lot more writing than I would normally do on one of these problems. If I was asked for the square root of negative 25, I would just say, well, square root of 25 is 5, it's negative, so it needs an I, okay? So when I look at square root of negative 36, I would just say 6I. That I just represents the fact that you were taking the square root of a negative, okay? So up until now, we've always just said this can't be done. It can be done with something called imaginary numbers. So let's take a look at example 2 here. This is some solving. X squared equals negative 100. If I was being asked to solve this, I would come along and I would take a square root on each side. And again, up until now, we would have looked at that and said, oh, no solution. Now we have a solution, okay? What we do still have to remember is when we're taking a square root, we get a positive and a negative answer. So we could have positive 10I or negative 10I, okay? Because when we take a square root of 100, we could get positive 10 or negative 10. And then the I represents the negative that was under the square root a second ago, okay? By the way, this notation threw some people on the exam, and so I realized that maybe we didn't cover it as well as maybe we should have. There's a shorthand way for writing this, and it's like this. X equals plus or minus 10I, okay? Now, you may be asking yourself, why didn't I worry about pluses or minuses up here? Because we were taking square roots. The plus or minus really is significant when you're solving, because solving is when you're saying what numbers could X be. And X could be positive 10I or it could be negative 10I. Okay, that's really what we're saying here. So with this next example, I would probably add 5 to both sides. 2b squared equals negative 50. Now, before I take a square root, I want to get rid of that 2, so let's divide by 2. I get b squared equals negative 25. Square root, square root. And if I'm working in the land of imaginary numbers now, I can say this answer is plus or minus, don't forget your plus or minus because you're taking a square root when you're solving, 5i. And that would be your final answer. Okay? Okay. So let's talk about some more stuff that has to do with I. This first problem just wants to know, what does I squared equal? This one is going to be really, really important. Okay? I squared. I itself is not negative 1. I is the square root of negative 1. So what this is really saying is, what's the square root of negative 1 squared? Well, a square root and a square cancel themselves out. And so I squared is just equal to negative 1. Okay? That's a very important distinction here. Let's see, how do I want to write this? I'm going to start up here. I is the square root of negative 1. I squared is just negative 1. Okay? These two things are important to know. But that means that anytime you see an I squared in a problem, you can go ahead and replace it with just a regular old negative 1, like you're about to see here. So when I do 6i times 4i, 6 times 4 is 24. And I squared, or I times I gives you I squared. Well, this is really 24 times negative 1. So this is just equal to negative 24. Okay? And so that's what happens. Anytime you have an I squared, you don't want to leave it in your problem. It just becomes a negative 1, which essentially just makes the number that it's attached to negative. Okay? So let's take a look here. I'm going to simplify each of these separately. Square root of negative 4 would be 2i minus square root of negative 49 is 7i. From here, this just works like almost like that was an x. So 2i minus 7i is negative 5i. And that's just where I leave it. Now, why didn't I say, oh, well, that's a negative 1, so it becomes a positive 5? Because that's an I and not an I squared. It's only I squareds that make the final answer change. Okay? So looking at this one here, square root of negative 36 is 6i. This would then be 3 times 2i. Okay? That's 6i plus 6i, which makes 12i. Okay? Now watch what happens on this next one. Square root of negative 25 is 5i. Square root of negative 81 is 9i. And then, when you have an I on the top and an I on the bottom, those should both cancel. 5 over 9 doesn't really simplify, so your final answer here is just 5/9. Now let's talk square root of negative 12, because that's not a perfect square. Okay, all these other ones I've done have been nice perfect squares that I can just take the square root and tack on an I. This time I don't have that. So I want you to think back to yesterday. Yesterday we were doing things like this. We were taking square root of 12 and writing it as square root of 4 times square root of 3, and then we could make this into a 2, right? Today I'm doing the exact same thing. I'm going to take that 12 and write it as square root of 4, square root of 3. But then what I want to remember is because it's negative, I also have a square root of negative 1 tacked on there. Okay, so this is just reminding you from yesterday. Don't really need that. So if you think about it this way, I'm breaking it down where one of the numbers is a perfect square, just like we did in class yesterday. One of the numbers is not. And then this negative 1 comes from the fact that this was a negative 12. Now I can translate piece by piece. So, and it's going to come out a little bit out of order, but that's okay. Square root of 4 is just 2. Square root of 3 I can't do anything with. And then square root of negative 1 is I. Now, the best way to write this would be to take that -1 and attach it directly to the 2. So it should look like this, 2i square root of 3, okay? Which is the same thing you would have gotten over here with the 4 and the 3. You would have gotten 2 square root of 3, and then just the fact that it's negative means you're going to get an I tacked on there as well, okay? Okay, let's take a look at example 4 quick because we're flying through this stuff. It says show that I square root of 7 is a square root of -7. Now, what I don't want to see you doing is writing down something like, oh, well, the square root of -7 is equal to I times the square root of 7. Look, I showed it, okay? That's not what I'm looking for here. I want you to think about, if I told you to show me that 5 is a square root of 25. If I wanted you to show me that, convince me of that, it wouldn't be enough for you to just say, well, because the square root of 25 is equal to 5. That's not showing me why that's true, okay? I want to know why do we know that's a true statement, okay? The way you would show me that is by taking the 5 and squaring it and saying, hey, look, when I square this 5, it turns into 25. That's why when I do a square root of 25, I get 5, okay? So that's what we're going to do here, is we're going to take this and we're going to square it, and we're going to show that when we square it, it comes out equaling -7, okay? Now, when I square something like this, I have to square both pieces. So I'm going to get I squared times the square root of 7 squared, okay? I squared, we already talked about, is equal to -1. And then square root of 7 squared, cancel, cancel, and you're left with just 7. And -1 times 7 is -7, which is what you wanted to show, right? You wanted to show that this is a square root of this, which means that I should be able to square this and have it turn into that, okay? So that's how you go about showing that something is a square root of something else, is by saying, hey, look, when I square this, it turns back into what I had before. Okay, I feel like that was a lightning fast lesson on imaginary numbers, but really that should be enough to get you through your homework for today. Homework is out of the packet. And if there are ones that are crossed off, I'm hoping that I already did that in the packet for you. Fairly certain I did. Okay? So have a great day. We will talk about this some more tomorrow, and then we're going to add in some other fun stuff with this too.